So far, we've always created matrices manually like this. There's a 2x4 matrix. But MATLAB has a few functions that let you create matrices of arbitrary size really quickly. Here's one. You can see what it gives you. Zeros, a matrix of all zeros, and this was a 5x6 matrix. What if you want ones? You can get those too. What if you want all fives? Well, that's the way you get that. Oh, and let's look at this. Just give it one argument. 4x4. This is another example of polymorphism. If you give it two arguments, the first one's a number of rows, the next one's a number of columns. If you give it one argument, you're giving the rows and the columns. If you want a vector, let's do ones. This gives you a row vector. If you want a column vector, we'll do it with zeros. And if you want a diagonal matrix, you can have that. Suppose you want a matrix with 7, 3, 9, 1 on the diagonal. 7, 9, 1. There you are. A diagonal matrix, of course, has elements that are non-zero only where the row index equals the column index. So here's 1, 1. This is 2, 2. 3, 3, 4, 4. We want to look at random numbers now. Random numbers are very important in many fields, such as signal processing and on and on. And MATLAB has some different functions to support this. We've seen rand in the last lesson, but let's revisit that one now. You remember rand? There. It outputs numbers between 0 and 1 that are uniformly distributed on that range, meaning that any number in the range 0 to 1 has the same probability of being returned by rand at any given time. And as we've seen, it can return matrices. This is one we did a lot of in a function called myrand. And like these other matrix producers, when you give rand one input argument, it treats that as a number of rows and columns, and you get a square matrix. In our previous lesson, we showed how to get a range other than 0 to 1 by combining rand with arithmetic operators. For example, here's how you get a 5x4 matrix of numbers between 1 and 11. But what if you want random integers in that range? Well, first note that the whole number part of these numbers ranges from 1 to 10. If we could just drop the fractional part, we'd have integers that go from 1 to 10. Well, MATLAB provides the function fix that'll do that. It returns the whole number part of a number. In other words, fix rounds the number towards 0. Let's just give fix the expression we just came up with. So I'm going to hit the up arrow. I'm going to put parentheses around this. There. There doesn't happen to be a 1 there that time. But these numbers range from 1 to 10. I'm going to repeat that command. And there you see some numbers a little bit different, and there is a 1 there. Maybe that's reassuring that it's 1 to 10. But MATLAB will do better than that. It provides a function that returns random integers. It's called randy. Rand I. And I'm going to give it 3 arguments. 10. You can see all these hints there. There's lots of different ways to call it. 5, 4. That 10 means that we want integers that go from 1 to 10. The 5 and the 4 say that we want a 5x4 matrix of them, and so there they are. And by now, you probably correctly guessed that Randy is polymorphic. If you give it just two arguments, the first one's still treated as the maximum possible integer, but the second argument gives the number of rows and columns of a square matrix. So Randy 25 will return a 5 by 5 matrix of integers between 1 or ranging from 1 to 20. You can also call Randy one other way. Well, more than one other way, but as you can see there, if you give a vector for this first argument of two elements, 5, say 10, that means you want numbers that range from 5 to 10. And now 2, 3 says that we want a 2 by 3 matrix of them. Many times we need random numbers that have a normal distribution instead of a uniform distribution. This is also known as the Gaussian distribution. Sometimes it's called the bell curve. Here's how you get that. You use the function rand n, the n's for normal. I give it a 5. Well, the inputs are the same. A 5 means a 5 by 5 matrix. The numbers range from -infinity to infinity, clustered about 0 with a standard deviation of 1. And a lot of times we want a lot of these numbers. Suppose you want 1,000,000 of them. Better not forget that semicolon. There, it didn't take long. Generated a row vector of 1,000,000 numbers distributed normally with a mean of 0 and a standard deviation of 1. Now let's look at this distribution using the hist or histogram function. Figure pops up and we see a nice little plot. You can see this bell curve here. The first argument is the set of numbers, the list of numbers. We've got 1,000,000 numbers there. And the second argument is the number of bins. So there's 100 bins divided up in a reasonable way. MATLAB does that. And you can see the number of points of the number of random numbers that was generated by rand n. In this little range right here around 0 is very large, and it drops off as we get out here and they get more rare and more rare. We've seen a number of ways to get random numbers from MATLAB. Now I'm going to tell you a dirty little secret about these random numbers. They're not random. For example, the first time we call rand after we start MATLAB, it returns 0.8147. That exact same number, every time. Go ahead, try it if you don't believe me. Not all that random, is it? And why is that, you may ask? Well, a computer is a deterministic machine. Everything it does is determined by an algorithm. There's no real randomness involved. So you don't get a truly random number. Instead, the random number generator uses some fancy math to generate a pseudo-random number sequence. It's pseudo because it seems to be something that it's not. But the sequence of numbers that it generates sure looks random because there's no discernible way to predict the next number from the ones that came before it. For almost any purpose, unpredictability is all we need, and that's what we get. Well, almost. When we start MATLAB, the algorithm is initialized the same way every time, so it generates the same sequence every time. Now that may seem like a bad thing, since it always gives us the same numbers. In fact, it's a good thing. It's a feature, not a bug, as the popular saying goes among us programmers. It's a feature because it helps us during the development of our programs. When we're developing a program, we often use the random number generator to give us many thousands of test cases. And just as often, we need to see what happens when we change the program but use the same input. Well, the only way to do that is to generate the same numbers repeatedly. So, It's very useful that MATLAB generates the same pseudo-random sequence each time it starts. Of course, restarting MATLAB every time you need to restart the random number generator hardly seems convenient. So MATLAB provides a separate function that will reinitialize the random number generator for you without restarting MATLAB. It's called RNG, which you might guess stands for random number generator. It takes an input argument, and it uses that to determine the sequence that RAND will produce when you call it. It also uses a neat trick that lets you initialize randomly. This trick allows you to get a different sequence every time you run your program, even if you restart MATLAB in the meantime. All this may sound complicated. It's really not. Let's switch to MATLAB and you'll see. Okay, to demonstrate this pseudo-randomness idea, I've quit MATLAB, and I'm going to restart and ask it for 3 random numbers. There, MATLAB's awake, and I'm asking for the 3 random numbers. And there they are. They look pretty random, I guess. Let me copy those to my clipboard. Now let's do that again. Let's quit and restart. You know, they look pretty familiar. Let's take a look at that clipboard. There. Yeah, that's the same numbers. Looks like every time MATLAB wakes up from oblivion, it starts all over at the same point. It's sort of like Groundhog Day. That was a great movie, by the way. So anyway, here's how to have a new Groundhog Day anytime you want it without quitting and restarting MATLAB. First, let's get rid of these numbers we pasted on here. And then I'm going to call RNG and give it an input of 0. Giving it that 0 as input resets the random number stream to the beginning, right where MATLAB always starts it when it first opens up. So we get the same numbers. You can use any other non-negative integer to start at a different place in the pseudo sequence. 1, for example. There, that starts us at a new position. And by the way, RNG sets both rand_n for the normal distribution and randy for the integers too. Let's look at those. I'm putting them all in brackets here so that they'll be on one line in one vector. And I gave randy 1 argument. When you do that, it gives back 1 pseudo-random number, I should say 1 pseudo-random integer, ranging from 1 to that argument. And you can start at that same point in the random sequence anytime you want to. We gave rand a 1 twice, so we started at that same position twice and got the same numbers both times. Or you can start at some other point. I went up arrow to get that command back, and I'm going over here to change this 1 to a 2. And of course, if I repeat that command, same random numbers again. If you want a more random sequence, an actual random sequence instead of this pseudo-random business, you can input a string, the string shuffle to RNG, like this. Let me go back, change my argument over here to the string SHUFFLE. Got to end that string with another single quote. Let's repeat that, see if we get the same thing. No, and let's repeat it again. We're getting different numbers in the sequence even though we're inputting the same argument to RNG every time. Well, how does that work? Well, it uses that trick I mentioned to start the pseudo-random sequence number stream at a random point. It does that by getting the current reading of the system clock to generate a truly random number. Since that clock has microsecond resolution, this is all but guaranteeing a random sequence that'll never be repeated.